I'll begin with a word of prayer. All right. Dearly Father, we thank you for this day. Thank you for this semester. Just ask that you'd help us to finish well, help us to use this time, Lord, wisely, and just to settle any remaining questions that there are, Lord. In my prayer, Lord Jesus. Amen. Let's see here. So let me get the solution out here, if I can find it. So I posted the solution to test 3, right, as well as a blank copy. So there's blank copies of test 1, 2, and 3. Well, sorry about that. The all right. Okay, so let us discuss test 3. I'll try to go somewhat quickly through this because we still need to talk about the other tests, right? So that's a circle. It's centered where x is equal to 0 and y is equal to 4, which means it's this one. This is 1 minus the natural log, so it means it's got a vertical asymptote at -2. That's this one. This is a circle, radius 4, centered at 2 minus 2. That's this one. This is a exponential function with a horizontal asymptote of -4, which means it's that one. So a lot of you got this right. Some of you are still learning. I think a lot more people got number 2 right than they did on the quiz, so that's an improvement. Some of you are still learning. Many of you still haven't worked out your demons in this problem. And the problem that you have is algebra. So you have to be careful and methodical in this. And you also need to, so a fair number of you, maybe 15%, 20%, I don't know, got halfway through this and then decided to solve for y. What happens if you get halfway through this and then solve for y? You get right back where you started, right? Which is why you put down the formula for the function as the formula for the inverse, but it's rarely correct. Yeah. You have to solve for x, and then that's f inverse of y. That was the rule there. Any questions? Just jump in. Yeah. Yep. Oh, you don't have yours. Well, that is a problem. Let's see here. Adeline or Brooke? That's right. There you go. Mm-hmm. All right, so again, this is posted in Canvas. Let's see here. So going down, vast improvement in this problem. I think most people got this one right. If you were a little bit off on this, I just took a point off, and now that you can look at the solution, you can see why I took a point off, I think. This one here. Trying to remember what I saw wrong mostly here. I can't remember. But that one's answer was 42. For problem 6, a lot of you forgot that when we have x squared equals to 9, you can get plus or minus 3. Others of you reflexively thought that the minus solution has to be extraneous. That is not the case. We have to think through it. Sometimes the minus solution is extraneous, sometimes it's not. Here it's not. Because if you plug minus 3 up into this, you get 10 to the minus 3 squared, which is 9. 9 minus 7 is 2. 10 to the 2 is 100. It checks. So the plus and the minus both work here. Yeah? So we can't just assume that the minus 1 is extraneous. You have to think through it. A lot of you got this one right, so hooray. All right. There's a lot of diversity in the wrongness here. So the test was very strong on problem 8 and problem 9. Very strong, lots of diversity. I did have a few people get the right answer here. They're pretty rare. A rare bird would get this one. Like that, okay. I mean, this was unintentionally tricky. It was a typo, but I already printed the test out, so I had to kind of like stick with it, you know. So here's how it goes for number 8 and number 9. So it's log of 1,000 plus log of x plus log of y squared plus log of z cubed. So of course I can bring down, well, first of all, log of 1,000 is log of 10 to the third power, which is 3. And we can bring the 2 out of the log y and the 3 out of the log z. But then the thing is, you're instructed to write it in terms of natural logs, right? So the change of base formula says you just divide by 10 like that. So, so I'm probably going to convert these kind of problems to sort of a multiple choice sort of format on the final, where I give you like 3 or 4 expressions, and then I give you 4 or 5 possible simplifications and say, it's this one, it's that one, it's none of the above. Something like that's probably the format I'm going to. Just so I can get a better sense of whether or not you understand, because it's hard for me to sort through what you guys are doing on these two problems. Anyway, this one here was simpler, because if we divide by 2, we get 1/2 log base 3 of c, which is log base 3 of the square root of c, and then we take exponentiate both sides base 3. That gives us a minus b is equal to root c, which gives us that. So.
Why is 1/2 log turned into square root? Oh, never mind. It's because it changes the power rule and then
Right. It's the power law for the exponential. That's it. Yep. But a lot of people got this wrong, so there's something to work on there. I would say more people got problem 11 right. There's something about putting numbers in a problem that just makes you guys do better. I don't know why, but because I would, well, anyway. So 2.31. So basically just solve for the exponential and then take the natural. So there's a fair number of people who managed to get to here and then did something, I don't know what you did past this point. You did something wrong with your calculator or something, because you didn't get to here. You got to some other number. So, but I did get partial credit, of course. This one here, some of you are still not hearing me. When we have a log of a sum, it's the log of the product, right? So you don't just, some of you are still just dropping the natural logs and adding these. That's not how it goes. Anyway, so, yep. And then, a lot of people managed to not be able to solve this correctly, which is unfortunate, because, or you looked at this and you're like, I don't know what to do. I'm not sure what happened exactly, but when we get to x squared equals to 4, then of course we can take the square root of both sides and we get plus or minus 2, right? But then the minus 2 in this case is extraneous, because when you plug it back up in here, you get log of a negative number, which is not allowed, because we like to keep it real in here, right? 13. So most of you got 4, which was a marked improvement over the last time this problem happened. And there's a few of you who found your way to 2 and minus 1 here, but a lot of you, I don't know what happened. Something happened in the algebra, went wrong, right? But I would point out on the final, if I give a problem like this and you have time, you can check your answer, right? Think about this. If this problem is worth 20 points of 200 on a final, that's 10%, right? Is it worth 5 minutes to like plug the numbers into the formula and see if it works? I think it's worth your time, because if they don't work, then maybe you need to take a second look at the algebra or try to redo it again on a separate page or something. I don't know. But here, if you plug the number back in, for example, plug 2 in, what happens? F of 2. 2 times 2 squared is 4. That's 8. 8 minus 2 is what? 6. 6 plus 4, 10. So I plug in 2, I get out 10. That's what we want, right? So we can check our answer here. And I don't know, maybe half the class got this one right. those of you who didn't, it's not too late. You can figure this one out. It's not that bad. Notice that this one is really nice. Look for this kind of thing. In this one, we can add the second and the third equations, which makes the y and the z both cancel out, right? Which gives you x equals to 3, and then you can kind of go from there. But that's the main thing, is just seeing, like, look for being able to add equations. If you can't, you can't. But if you can, this is super nice, right? So I would say that if I had to guess, if I was to give 3 equations and 3 unknowns on the final, it's very likely that it follows the same pattern, all right? In contrast, it would be much meaner if I was to put one on the final which didn't follow this pattern and made you go through the algorithm that I wrote out in class, right? I would say that that's unlikely. That's it. Any questions? So there's a lot of people with some pretty low scores on this test, but all is not lost. There's still I don't replace just one test with the final exam grade. I will replace up to 3 test grades with the final exam grade. I don't think every section does that, but I do that. So if you improve on the final, then you can, make this score go away in some sense, right? And so I guess the next question is, what is on the final, right? And so the answer to that question is, I would look at quizzes, 1, 2, and 3, and tests 1, 2, and 3. That's where I start. Pretty much I look at those things, I copy, I paste, I change numbers. I do invent a couple new problems for the final that are based on the concepts, but not, exactly the same. For example, that multiple choice question I was just talking about for the simplifying logs would be an example of that. But anyway, what would you guys like to talk about? The floor is yours.
You can only add points by doing one on the final, right?
Oh yeah. I'm not like, oh, you made a 30% on the final. Now I'm going to go back and take that 100% you made on test 1 and like swap it out with the 30. No, that is not what I do. It only helps. Yes. Yeah. Of course. What would you like your name to be today? All right. Yes. There you go. Uh-huh. Let's see here. Problem 8. So this one here, yeah. We have log of x squared. The 2 comes in. Then we have log of the square root of x, because that's the 1/2. So we go log of square root of that. And then the minus, well, I just left minus alone, right? That's the hand. I don't know what that is. So then, so we have log of x squared times the square root. And then we divide by z because there's a minus there. So yeah, sorry, number 9 worked out harder than I had hoped. Like, I was not intending to make this problem so hard, but unfortunately I'd already printed it by the time I noticed it. So, and my experience is when I try to like modify problems in class by verbal communication, it never goes well. So I decided to just stick with what's there since it's logical, even though a little bit harder than I intended. So, hey, let's go back to test 1 for a minute, yeah? If I can. Let's see here, where was that? Let's see here. So any questions about this test 1 material? I hope you guys are better at factoring now, right? If you go back and you try these factoring problems on test 1 that you got wrong then, do you think you can get them right now? I mean, I hope so. No? Well, if not, then I would work on that, right? You do get 3, you can bring 3 sheets to the final, right? So if you're weak on this, a smart thing to do would actually be to put these examples on your sheet just to remind yourself how it goes, right? The numbers will be different on the final, but maybe you can, you know, adapt the pattern to your final or something like that, right? We had this completing the square problem that was, this threw a lot of people for a loop, didn't it? Because we had to factor the 2 out, which was just something we hadn't done a lot right before the test, but just a little bit. So the 2 comes out, and then we complete the square there and factor like that. Let's see here, what else can we talk about? It's been a little while since we simplified rational expressions. What's the general rule of thumb? Is look for a common denominator to make things go together, or look for things to cancel so that they have the same denominator, right? Division by a fraction is multiplication by the reciprocal, right? And again, we look for common factors to simplify. We could solve all quadratic equations by the square root property, right? So you can complete the square if you don't have a square root already. Now this one already has the square completed to start with, right? So we just take the square root of both sides. But notice the square root of a negative number gives me an imaginary answer. So I get complex solutions there. Now part B is easier, right? Because that's just plain factors. So we don't even need to use completing the square. We can just, you know, factor that and solve it. Something to keep in mind. Some of you are still struggling with this issue in its sort of more recent versions, which is that when we factor as x plus 3 times x minus 2, remember it's the value that we put into x that makes the 0 that's the answer, right? If we're looking for the solution. So I don't put 3 over here, I put minus 3. I don't put 2 over here, I put 2, right? This is the same issue that some of you are having with like identifying the center of the circle in those problems, right? We have to mind the minus in the formula. This gave you guys a lot of trouble. A lot of people had a lot of trouble with this. I think if you look back at it now, you should see it's not that bad. Like the domain are the possible x values on the graph, right? So like minus 6 included all the way over to 4, right? Minus 2 is included right there. And then 4 to 8, so those are the x values. And then the y values go from minus 4 all the way up here to 6. And the minus 4 is not included because of that open bubble down here, but the 6 is included because while there is an open bubble over here, there's a closed dot over there. So how did I see f of minus 2 was 4? Right, yeah, right here at negative 2, go up, that dot right there told me it was 4, right? When we have a problem involving a square root, what do? What you have to do is isolate the square root, right? So the first thing I did was to isolate that square root. 3x equals to the square root of 4x plus 5. A wrong thing a lot of you guys did here was like you squared this and kept the minus between the square, right? But when we square, if you have like if you have a difference of things and you square it, what happens? What happens when you take a minus b and you square it? What happens to that? See, what that means is a minus b times a minus b, right? And then when you multiply that out, it gives you a squared minus 2ab plus b squared, right? So if you just square the equation as it's given to you here, it's not productive because you get this middle term, you know, which would still have a square root in it if we think of this as a and that as b. So the smart thing to do is to isolate the radical and then square. So as a rule of thumb, if we have a problem with a radical, isolate the radical, then square. Or cube if it's a cube root. Yeah. And interesting. And then this was an ugly quadratic, so I decided to just use the quadratic formula on it, right? Which is our sort of weapon of last resort for solving a quadratic equation. Although I felt kind of stupid after I did it because I was like, oh, well, I guess the 1 is, it's 1 or minus 5/9. I guess that's kind of, factoring minus 5/9 is one of my roots. It would have been ugly. Now this one is extraneous because if I go plug it back in, it doesn't work. And that's oftentimes the case with one of these problems with the radical. If you have two answers, typically you'll lose one. I think that a lot of you had a lot of problems on this one, if I remember right. Have you figured out what went wrong there? I don't know. Only you know, right? So this one, whenever we're solving an inequality, what we look for is places where the expression's either 0 or undefined. We put those critical numbers on a number line, and then we check cases, right? Test points in each case. We could use the sign flip theorem, right? Like this x plus 7 is with a square, so it stays minus going from one side to the other. Like minus x plus 3 corresponds to the minus 3 here. It's a power 1, so we get flipping from minus to plus. Likewise, the 8, it's cubed, so actually everything here except for the square term is going to have a sign flip, right? At minus 3, at 8, and at 5, like that. So you draw the sign chart, and then the question is, are you looking for greater than 0 or less than 0? If you're looking for greater than 0, you look for all the places where there are pluses, and that's your answer. So let's see here. And this one's a little bit tricky because, why? Because I get the bulk of it, minus 3 to 5, not included, and 8 to infinity, 8 not included. Why are 5 and 8 not included? Well, because you got division by 0, right? So I have to throw those out. But this is greater than or equal to 0. So I'm also looking for places where this expression's 0. And notice that minus 7 is such a place, right? So that's why I had to union with minus 7, because that also gives me 0. So this one's a little bit tricky in that regard. Now, listen, if you gave your answer as everything here except for minus 7, and it was a 20-point question, I would only take like 2 points off. So I view this as like, like a 10% error. It's not a super big error, missing that. So it's good to you should review this because you've probably forgotten. If we have absolute value less than something, we can unwrap it as a compound inequality. But if we have absolute value greater than something, it splits into two separate cases, right? This was the big idea. So there's a very big difference between a less than problem with absolute value and a greater than problem with absolute value, right? If I were you, I would make sure I had an example of this on my formula sheet, just to remind myself how it goes, But, it's lovely if you have all these examples on your formula sheet, but unless you understand, it's like copying the example down to your formula sheet is not studying. I mean, it's part of studying, but it's not the end of studying, right? Because there is no earthly way that you can have enough time in the final to go through the process of learning the example to translate it, right? You have to do some of that learning in advance. You need to understand things before you take the final. So copying some examples down like that on your formula sheet, I would say it's like a lifeline, right? But you need to have more familiarity with it, otherwise you're just not going to have enough time to translate that information. So what's the sort of overarching theorem that I'm referencing here? Let me write it down again for you guys. The overarching theorem is just this. If we have absolute value of A is less than B, that is equivalent to minus B less than A less than B. And if we have absolute value of A is greater than B, that's equivalent to A less than minus B or A greater than B. So basically those are the two rules, and you can adapt them for different choices of A and B. Whatever A and B happens to be equal to here, it was equal to, B was equal to 1, and A was equal to 5 minus 2x for the first part, right? Now, there is some fine print here. What do we need to, what needs to be true about B here? What condition must be true for B for these to be logical? There's one string attached to this. Yeah, B has to be a positive real number, right? And I'm usually asking for answers in interval notation, right? So I think you guys know what that means for the most part. How do you find a parallel line? What makes a line parallel? What? Same slope, right? What makes a line perpendicular? Negative reciprocal slope, right? So the given line has slope -4, so the parallel line has to have slope -4, right? And the perpendicular line has to have slope -1/-4, which is 1/4. And then I'm just using the point slope formula, which means you put the y here, and you subtract the x over there, you put the slope that you want. So this is just using the point slope formula for a line. But, okay, let's go on. See, it's less likely that this problem appears on the final because the truth of the matter is this is prerequisite material. This was supposed to be covered in like your intermediate algebra class or high school algebra, whatever. I mean, that was test 1. Let's go back to test 2. Come on. Well, I'm trying. Let me out. Come on. Come on, Canvas. You can do it. What do you think the odds of completing the square being on the final are? 100%? I'd say that's probably true. Have I not posted the solution to test 2? No. Guys, you guys got to tell me that kind of thing, you know? Just email me if you miss it. If I'm missing something like that, just email me. I will post it. Oh, yeah. I wonder if it's just you guys. If I haven't posted test 2 in all 4 of my sections of college algebra, and not a single student has emailed me about this, it is not a good omen. Let's see here. Rats. Oh, apparently I haven't posted the solution to test 2. Obviously I mean to do that. Let's look at quiz 2 because it is a suitable alternative. Like I said, I look at the quiz and the test to make the final. Yep. So list of things for me to do. I will post the blank test 2 and its solution. Hopefully once business is done today here. Well, I was trying to make it bigger. Here we go. As you may or may not recall, this right here is not in the picture. So the graph of this is actually like the red thing here. So I had to fix that. Here I asked you to find the coordinates of the vertex and the x-intercepts. Remember, we complete the square. Right, to find the vertex is 4 minus 5. And then I can factor like that. Once I factor, I can read off the x-intercepts as 4 plus or minus root 5, comma 0. Now, so I just asked the question, do I have to ask about completing the square? I mean, yes and no. If I want to test on completing the square, but I don't want to have to actually say the words complete the square, the simple way to do is to ask you to find the coordinates of the vertex, right? Because pragmatically speaking, you really want to complete the square to do that, don't you? And the same for finding the center and the radius of a circle, right? Both of those problems require completing the square. Now this one here, remember we graphed rational functions, so the way to do this was to factor, and if there is, you know, a balancing factor above and below, that gives you a hole in the graph. If it's just upstairs, it's a 0. If it's just downstairs, it's a vertical asymptote. So this is going to have a vertical asymptote at -1, x equal to -1. It's got a x-intercept at -2, comma 0. And the hole in the graph I get from plugging in the place which is undefined into the reduced function. So the reduced function, I just divide out the hole in the graph factors. Leaves me x plus 2, x plus 1. I plug in 2, and I get 4/3. So there was the where the hole in the graph was. I know it's been a little while since we did that. A lot of you had a lot of problems on this one, and that need not be the case. This one's actually very easy. I would encourage you to look back at number 4 here. The graphing on the quiz had a horizontal asymptote of -2, but on the test it did not. And a lot of you just mechanically assumed that there was going to be a horizontal asymptote at -2. And you need to think through things. Don't just assume it's going to be exactly the same. It might not be. Now, problem 6. So problem 6 is got an important idea in it, right? Which was the factor theorem. If we evaluate the polynomial at 1 and we get 0, that means x minus 1 is a factor. If we evaluate the polynomial at 2 and get 0, that means x minus 2 is a factor, right? So I can multiply those out, and I get x squared minus 3x plus 2 is a factor. And so that means that I can divide, if I can divide that in, that'll show me what the, let's say, cofactor of it is. So this shows me that I factor x minus 3 out of that to get f of x, and then of course you can undo the factoring, undo the multiplication to go back to the factoring like that. So if you're rusty on your long division, it's probably time to review, right? Problem 7. Here we had a complex zero. What was the complex zeros theorem? Complex zero said that if I've got 1 plus 2i, that means I'm going to have an x minus 1 squared plus 2 squared, which is 4, as a factor. So this is easy to use it if you know it, and it's just, you know, Asgardian magic if you don't, or whatever. Pick your favorite thing you don't understand. And so I have this factor, I have that factor, which means then, since I'm third order, that's all I've got, plus the multiplication, plus the factor out front, which I can adjust, and then I figured out I have to make it -2. The question asked it for in standard form, which means you got to multiply it out, right? Unless it asks you explicitly to put it in standard form, don't do it, right? Like, this is a good answer, don't multiply it out, because I didn't ask you to multiply it out here, right? Let's see, how did it go here? We had a bounce at -2, right? That's why I had x plus 2 squared, but we have crossings at -6 and 4. That's why I have x plus 6 and x minus 4. And so that's how that went. And then down here is yet another long division. And so there was that. I had a problem on test 2, which was kind of a little bit tricky. It was long division, and then I asked you to calculate the value of the polynomial at a particular complex number. So that's kind of an interesting problem to look back at. I would say that that aspect of the problem is in some sense bonus, but yeah, that's pretty much it, right? The test is going to be what? On factoring, graphing polynomials, rational functions, you know, obviously algebra, all the kinds of algebra we've talked about, but more recently solving exponentials and log equations, right? Finding the inverse for a function, graphing the inverse, you know, all the things we just talked about on test 3. So it is comprehensive. That's just pretty much it. So, hey, so did you guys understand what I told you about the grade book? Do you have any questions about that? So, like, what's going on is I may have forgotten to, but most sections I have checked, I have made the homework points not count towards the total, because what I'm doing is I'm going in, I'm downloading them, I'm adding them up, rescaling them, and putting them in the total homeworks column, and that will count towards the total in Canvas. So that way you have the actual number of points that you've earned in homework overall, which could be up to 200. Now there's 370 in my lab, so I have to take the number you've actually earned and divide by 370 to get, multiply by 200 to get the actual homework points. So there's like this total homework points column, and I also have the total points earned column, which just adds all your points that you've earned, including, like, you know, quiz 1, quiz 2, quiz 3, test 1, test 2, test 3. Oh, not test 3 yet. That's not included there yet. I haven't entered the test 3 grades into Canvas yet. And what else? Oh, the participation grades, they're all posted, right? So everything's posted except for what? Test 3 and the final exam. Obviously, you haven't taken that yet, right? And what else is not posted? The other thing that's not posted is all the remaining points that you guys are earning in the homework, right? There's still a day or two, right? Is there a day? Yeah. So those are points that you can earn. And I will update the homework score again. So, like, the homework total's not final. That's just everything that was there up to the point I did that. All right, so I'm going to upload your scores again and refresh that column once we get like to the past the final exam. Yep.
So you're saying that the homework total and the total points note like this, is that already included in that? Or do I
Yeah,
add
the
them
homework
together?
total includes the total points includes the homework total, and now, but the total points earned is not final, obviously, because like I told you, I'll replace your test grade with the final exam grade if it's helpful, right? Suitably scaled, obviously, because tests are worth 150, whereas the final exam is 200 points, right? So it's not a direct substitution. It's appropriately weighted substitution. But your total points could be improved by the final exam. So like nothing's final until the final exam, ultimately speaking. So
Is the whole final multiple choice?
I think I can tell you this. At the moment, everyone's failing the class
Yeah.
because no one's taken the final yet. So it's pretty much impossible to pass the class until you take the final, right? Okay, that's not entirely true. There's some of you after I entered test 3 grade and you've passed the class, right? But no one has an A yet, that's for sure. Right? This only happens after you take the final. Yep.
So is that the modified test total after we take the final and then we adjust?
Yes, the modified test total is where I will put, basically I just take like maximum final exam grade, comma, test 1, and like I take the final exam, I divide by 200, I take test 1, I divide by 150, max of those, multiply that by 150, that gives you the points that you've earned for test 1. I do the same thing with test 2 and test 3. And that way you basically, if you make a 90% on the final, you made an 80% on test 1, then your test 1 becomes a 90% after the final. So, yep.
How many questions are on the final?
How many questions are on the final? I don't know, I'm still editing it.
And is it all multiple choice?
And it is not all multiple choice. Oh my goodness. No, there's just, I think there's probably like a token, like a couple of the graphing problem multiple choice. I like those. I think those are helpful.
Oh, so it's not going to be the Scantron test?
Oh no, it's not Scantron. No, it's on paper, in class here, like you take tests 1, 2, and 3. Yeah. So I think that's it for today. I'll stop here.